Have you ever wondered if someone, like a friend or maybe even a loved one, give this string of numbers to you? Maybe they're being secretive, but you have no idea what does this really mean. What does this string number even tells you? So today I'm going to show you how to decrypt this string of numbers. Well, not this string of numbers, because I'm going to give you another example, and even encrypt a word into this string of numbers. So maybe you could even send this string of numbers to your friend, so maybe they could even interpret it. So let's go. Well, wait, but before that, this string of numbers mean trap. If you saw it, then congrats. Now then, let's go. So what I'm going to teach you first is how to encrypt a word into a string of numbers like what you have seen earlier. But before that, a warning to you all is that what I'm going to teach you is about matrices, like this example 2 3 1 2. This is a 2 by 2 matrix. So if you have no idea what matrices even are, then you could just search on other sites on YouTube, so maybe you could learn about them, because I will talk about terms like adjoint. I'm just going to write it here. Inverses. Wait, this is going long. I'm just going to use this. And then determinant. Oops. Why? Maybe I need to highlight this. This is awkward. Okay, like these terms, adjoint, inverses, determinant. So if you have no idea what these terms really are, then please just search them on others, since I can't explain it right now. Maybe I'll try to explain it like next time, but right now I can't. So yeah, if you have no idea, then please leave and just search those terms, so that later on you could go back to this channel and then learn how to encrypt and decrypt. So now that I told you about this warning, let's get in on it. So encrypting is the process of translating a word like this word trap into a series of strings of numbers like what you have seen earlier. So I'm going to teach you how to do it. Now then, let's go. So first of all, we need to separate this into three sets of words. Like what I mean is this: DRA, PPE, and then D. Since there's no other words besides D, since this is only one word, then we're just going to put some spaces in it. Okay, now that we have three letters that has three sets, we're going to convert them into alphanumerical. What I mean is where A is equal to 1 and Z is equal to 26, like so. So T is equal to 20, R is equal to 18, A is equal to 1. Okay, space. P is equal to 16, another P, so that means it's 16. E is 5, then D is 4. Now for these spaces, let me highlight it. Now for these spaces, this means that it should be 0. Or maybe you could put it as 27, whatever you prefer. Maybe 27. Depends on you. But since I'm very lazy, I'm going to put 0 in it. Anything goes. Now then I'm going to remove this. Okay, since I have a alphanumerical code now, I'm going to put them in a 3 by 1 order. So since earlier you saw 2018 1, then we're going to put them in this order: 2018 1, 16, 16, 5, 4, 0, 0, like this. Now that we have a alphanumerical in a 3 by 1, we need a 3 by 3 key. So this key, this 3 by 3 key, let's just denote them as A, B, C, D, E, F, G, H, I. This key will serve as an encryptor or a decryptor to turn these words, these numbers into a string of numbers like you see earlier, or will serve as a decryptor to turn the string of numbers, like let's say 420, 19, 18, into a word, let's say key. So I have here a 3 by 3 example so that I could just tell you the results. So I got 19, 15, that's a bad number, yeah, like that, that's good. 19, 15, 4, 1, 18, 11, 19, 15, 19. Okay, this is my example of a 3 by 3 matrix. And oops, this is very bad. 3 by 3 matrix. So I got here a 3 by 3 matrix, and I'm going to multiply it to each and every 3 by 1 matrix, but it needs to be in here. What I'm saying is that each and every 3 by 1 matrix is supposed to be here so that it's proper, or else your professor will get angry at you. Because as you can see here, the inner is correct, therefore it's possible. Because if you just put it like here, like what I did here, 2018 1, it will just be a 3 by 1. And since the inner is not the same, therefore it's not possible to multiply it. So that's what I'm pointing out. Okay. Okay, so I have put this 3 by 3 and 3 by 1 matrix off camera so that you don't have to see me writing this painstakingly. So we're going to multiply this. That will result in a string of numbers. Since this matrix is a 3 by 3, this key is a 3 by 3, and this our alphanumerical is 3 by 1, therefore the resulting will be a 3 by 1. Since this 3 by 3 is possible, then we could say that the resulting matrix will be a 3 by 1 also. This will turn into a 3 by 1. Okay, so let's now multiply. So I'm just going to write these brackets. Okay, we're now going to multiply. So 19 multiplied by 20. How do I put this? Okay, 19 multiplied by 20 plus 15. Oops. Oh well, I can do that. 15 multiplied by 18 plus 4 multiplied by 1. Okay, I'm going to explain this. So we're going to multiply it diagonally. So what I'm saying is 19, this 19 multiplied by 20. There's a pattern here. 15, we're going to multiply it 18. 4, we're going to multiply it by 1. So that's the pattern. I hope that you realize what the pattern is. I'm not good at explaining it, but I hope you realize it in this next example. So next string of number is 1 multiplied by 20 plus 18 multiplied by 18 plus 1 multiplied by 11. So I'm going to repeat this again. 1 multiplied by 20, 18 multiplied by 18. 11 multiplied by 1. Now, I hope you realize it already. The next setting of numbers is 19 multiplied by 20 plus, oh yeah, by the way, it's always plus. It's always in addition sign. 15 multiplied by 18 plus 19 multiplied by 1, which will just be 19. Alright. So, this will result to, wait, let me just calculate it. Calculator. 654, 355, and 669. Like what you have seen earlier, way back the video, this is the first part. Okay, now for the second part. I'm just going to reverse it. Okay, oops, it seems that it cannot be reversed. I am just going to cut this and just paint it green since I like green. Okay, our next alphanumerical code is 16, 16, and 5, and we will multiply it again. Now, the resulting will also be a 3 by 1. Now, again, 19 multiplied by 16 diagonally, 15 multiplied by 16 plus 4 multiplied by 5. 19, 16, 15, 16, 4, 5. Alright, next, 1 multiplied by 16 plus 18 multiplied by 16 plus 11 multiplied by 5. Okay. Let's double check. 1, 16, 18, 16, 11, 5. Okay. Next, 19, 16 plus 15, 16 plus 19, and 5. Which will in turn be 19, 16, 15, 16, 19, 5. Okay. Since that's correct, the resulting should be this. Since I already calculated it off camera, the resulting is 564, 359, and 639. This will be the result of this if you simplified it enough. Okay, and the last but not the least, okay, 400. Well, again, we will multiply it. 19 times 4, and the others are just 0, 0, 0. 4 times 0 is 0. Now, again, 1 times 4 is 4. 18 times 0, 0. 11 times 0 is 0. Plus 0, plus 0. If you want to put zeros in it, go ahead. But since I'm lazy, then, yeah. 19 times 4. 19 times 4 plus 15 times 0, 0. 19 times 0, 0. And the resulting string of numbers will be 76, 4, and 76. And if you compiled it into a string of numbers, it will it will result to this: 654, 355, 669, and so on and so forth. Just go back to the beginning of the video and you will see again the trap secret word. Alright. Now we're going to move on to how to decrypt using the key that we have. If you look at the time right now, it's 1:16 AM, and you might be wondering why did it took so long? Why is there a jump cut from that time from here? Well, it's because my file got crashed. I don't know why, but I guess I'm going to repeat it again. Okay, anyways, we're going to find the determinant, the adjoint, and the inverse. Again, if you have no any idea what are those terms, please search those on YouTube. Well, I'm going to explain it how in my way, but if you still have no idea what are those terms, then please just leave and maybe just encrypt. Well, anyways, I have here an example on how to decrypt, since earlier we're not going to decrypt that because the inverse of that is very much large. Okay, so what's my example here? Okay, my 3 by 3 is 2, 5, 19, 5, 5, 3, 8, 0, 0. And then my hidden word, well, I already know what that word is, but the hidden word is supposed to be, I'm going to write it here, 461, that's 4, 166, 152, 170, 105, and 40. These are the secret code that we're going to try to interpret on what it is using this key. Alright, to decode this string of numbers, we need to find the inverse, adjoint, and determinant. But first, we need to find the determinant. So I'm going to do what you call the cross-weaving method. It probably is different from other internationals, but I'm going to do it my way because I think that's much more simpler. 2519, 25, 553, 55, 80080. So what I did is I just copied these two columns and then just copied it here. So I'm going to do the cross weaving method. So I'm going to highlight this, and this is 19. It's not 1 and 9 separately, it's 19, 1950. And I'm going to highlight another one, which will be this 85 and 19, 032 and 055. Okay, now then, after that, we're going to multiply those. I have here, wait, where's my paper? Where's my answer to those determinants? I can't see the paper. Oh no. Wait, I'll just pause this. Okay, I already found my paper. I already know the determinant, but I'll teach you rather. Okay, so in these gray lines, we're going to multiply it, each numerical number. So 250, 2 times 5 times 0, that's 0. So I'm going to write 0 here. Okay, that's 8, that's not 0. And we're going to add each gray lines. 5 times 3 times 8, that's 120. 19 times 5 times 0, that's 0. Alright, now we're going to move aside and remove this aside, and we're going to multiply these blue lines. 8 times 5 times 19, that's 760. 0 times 3 times 2, that's 0. And 0 times 5 times 5, that's 0. Okay, now that we have our answers, which is 120 and 760, we're going to subtract this, which will in turn be negative 640. That's our determinant of this matrix. Okay, I'm going to pause this since... Okay, I just pause it because I'm just scared that it might corrupt again. So yeah, I'm back. So after we found the determinant, which is negative 640, we're now going to find the adjoint of this matrix. Alright, so this, I don't know what you call it, I already forgot, but yeah. We're just going to put plus and minus signs on each of the 2 by 2 matrices. So like so, like this. Oh my goodness. This is a bad drawing of an adjoint of a 3 by 3 matrix. Please don't copy me. Okay. After we drew this, through this diagram, remember that it should be alternating signs. So plus minus plus, minus plus minus, plus minus plus. This is nothing. Okay. We're going to use what you call the highlight method. I just called it right now. But if there's a official term, just comment down below and tell me what's the official term. Okay. We're going to highlight this number 2. And we're going to look at this 2 by 2 diagonal of 2. And we're just going to copy down 5, 3, 0, 0. Alright. And we're just going to put it here. 5, 3, 0, 0. Okay. Next pattern is we're going to highlight this numbered 5. Okay. And then we're going to look at this direction of its diagonal. So the next will be 5, 3, 8, 0. 5, 3, 8, 0. Okay, the next we're going to highlight is number 19. And we're going to look at only this direction, just like what we did to 2. Now this is what we're going to look, which will be 5, 5, 8, 0. Okay, now we're going to highlight numbered 5 in this row, for this row. And we're going to look at this row, at this diagonal. 5, 19, 0, 0. 5, oh, that's an S. 5, 19, 0, 0. Alright, now we're going to look at highlight number 5. Okay, we're going to highlight this. And we're going to look at the diagonals. 2, 19, 8, 0. 2, 19, 8, 0. Okay, this is 8. This is 8. Okay, remember that this is 8. Okay, now we're going to look at this number 3, which is, we're going to highlight this number 3 and we're going to look at its diagonals. So it is excuse me, we're going to look at this 2, 5, 8, 0. 2, 5, 8, 0. We're going to make this 2. I'm bad at drawing. Alright, now that we're done, we're going to highlight this number 8. 5, 19, 5, 3. 5, 19, 5, 3. We're going to highlight numbered 0, this 0. 2, 19, 5, 3. 2, 19, 5, 3. Are you seeing the pattern already? I hope so. Well, I'll make a video someday on how to do the adjoint of a 3 by 3 matrix. Then we're going to highlight this numbered 0, 2, 5, 5, and 5. 2, 5, 5, 5. Okay. Now that we have the adjoint of this matrix, we're going to find the determinant now of each and every 2 by 2 matrix in this big matrix. Okay. I'm just going to put this. This will serve as the equals of this. Okay. So the determinant of this 2 by 2, so 5 times 0 is 0, minus 3 times 0 is 0. So it will be 0. Now this 5 times 0 is 0, minus 0 times 19 is 0. That means it's 0. 5 times 3 is 15, minus 5 times 19. Okay, I'm back. So again, 5 times 3 is 15, subtracted from 5 times 19, which is 95. So 50 minus 95 is negative 80. We're going to write it from here. 5 times 0 is 0, minus 8 times 3 is 24, which will be negative 24. But since this is a subtraction sign, then negative of negative 24 will be 24. So the result of this is 24. Okay. 2 times 0 is 0. 8 times 19 is negative 152. So that will be negative 152. And I'm just going to skip this process. Well, you already know. So I'm going to repeat this again. You just multiply this first. 5 times 0, 0, and 8 times 5 is 45. Wait a minute. Okay, after viewing the footage, it seems that I deliberately says that it's negative 45. That's super awkward, therefore I took a long break after that. Okay, so anyways, I deleted all the footage about my awkwardness, so I'll just repeat it again. So since this is our result of our adjoint, as you can see in this video play, we're going to find the inverse using the adjoint and using the determinant that we did earlier. So how do you find the inverse? So inverse, it denoted as this, is equal to the determinant 1 over determinant multiplied by the adjoint. Okay, so since our determinant is 1 over negative 640, we will multiply okay, that's a bad negative 640. Okay. Now since this is a determinant, we're going to multiply it to our adjoint, which is this, which will result to this inverse. You'll just have to multiply negative 1 over 640 to 0, negative 1 over 640 to this 0, and so on and so forth, which will result to this. So the inverse, if you multiply each and every matrix, each and every element of the matrix rather, will be 0, 0, 1 over 8, negative 3 over 80, 19, oh, that's not a good 0, 19 over 80, negative 89 over 640. Oh, we're now going outside of the matrix column. I'm just going to delete this. One over 16, negative 1 over 16, and 3 over 128. This is the result of multiplying negative 1 over 640 to the adjoint. Alright, now that we have this inverse, we're going to multiply it to our given decode, given string of numbers rather. Wait, I'm just going to rewrite it again. Okay, I have this written the inverse again in a much more clean way. Well, it's not really clean, but alright, this is our given code, and we're going to decrypt it into a word. That's our agenda. So using the inverse of our given matrix, we're going to multiply it into this word. So first we will split it up again into a 3 by 1. So since this is good, then we're just going to put it in like so. 4 over 61, 166, and 152. And we're going to multiply it again. So 0 multiplied by 461, that's 0, plus 0 multiplied by 166, that's 0. 1 over 8 multiplied by 152, that's 19. And so, since the total of this, oh, I forgot this addition sign. So, since the total of this is 19, and if you convert it to alphanumerical again, that will be turned into S. So, 461 is equal to S. Next, negative 3 over 80 multiplied by 461. Wait, I'm just using my calculator. Wait, where is it? Well, I don't need the calculator since I already have the answer. So, negative 3 over 80 multiplied by 461 plus 19 over 80 multiplied by 166 and negative 89 over 640 multiplied by 152, which will in turn be 1. So again, negative 3 over 80 multiplied by 461 plus the product of this and the product of this. Now, we're going to multiply 1 over 16 multiplied by 461 plus the product of negative 1 over 16 and 166 plus the product of this and 152, which will be 22. And you can just do the others since it's already 2 a.m. I guess that's going to be your project, I guess. I have forgotten to mention this, but a is equal to 1 and b is equal to 22. Well, that's how you do the encryption and decryption of a given matrix. I hope you understand something. If you have any questions, please drop down comments down below and I'll just answer it next time or in the next video.